welcome to this webinar on correlation. I'm Dr. Robin D. Middlestat, and I'm very happy to be your mentor. Let's get started. This webinar will cover the concept of correlation, which is a measure of the relationship between two variables. We'll look at the types of correlation and the strength. Then we'll look at a number of scatter plots. Looking at scatter plots is one of the best ways to learn about and to understand correlation. It gives us a visual display of what's going on, so it's really easy to understand. Then we'll take a small data set and we'll use that to create a scatter plot. And finally, we'll compare our scatter plot to output from a statistics software program called IBM PASW, also called SPSS. Correlation is really a cornerstone to understanding business statistics. With correlation, we can gain insights into the impact of key social and business variables. We'll be exploring now the types of correlation and the strength. In order to determine what type of correlation exists, we look at the direction of the linear relationship. For example, a positive correlation occurs when both variables increase in value or if both decrease in value. And our data set will have an upward sloping direction. So if we have data points that look like this, and we want to draw in the line, it's going to look something like this. And you see it goes in an upward sloping direction. This tells us that as my x variable increases, 2, 4, 6, 8, 10, my values on y also increase. So this dot here is a 2 on x and a 2 on y. As I move up, I have a 4 on x and a 4 on y, and so forth. A 6 on both, as one goes up, the other goes up. And sometimes our data points fall outside of that line, but they both increase together, or they both decrease together. You'll notice that my R value is going to be between 0 and a positive 1.00. When we have a negative correlation, we find that our variables move in opposite direction from each other. This is an inverse relationship. As values on x increase, values on y decrease. So if I plot some points here, if 2 is on x, I look up here at 10, so x is low and y is high, it's up on 10. I move over here and I get a 4 on x and I go to about an 8 on y. So what I'm doing is a 4 on x and an 8 gives me this point. A 2 on x and a 10 on y gave me that point. A 6 on x and a 6 on y gives me that point. So I'm going to erase these now. I don't interfere with my pretty scatter plot. That's where I'm getting those values. I'm going to put some points on here like this. So with a negative relationship, I draw my line through these points, and my line goes in a downward sloping direction. You'll see that now my R value is going to be from 0 to -1. If there is no significant correlation, our data points don't seem to follow any type of consistent pattern. So if I have a value on x and a value on y, I might be low here on x, low on y, low on X, now high on Y, low on X, now in the middle on Y, and so forth. Higher on X, high on Y, middle on Y, even higher on X, low on Y, higher on X, high on Y. So if I just have a lot of data points all over the place, like this, a great big cloud, where would I draw a line? Well, as it turns out, with no significant relationship, we draw our line in a horizontal fashion, and our R value would be close to 0. The second scenario in which we might find no significant correlation, no linear relationship, is when data points fall in a curved pattern. And this, in fact, is called a curvilinear relationship. If I try and draw a single straight line, it's impossible to do it. In fact, I'm going to have to draw my line following the dots, and it's a curve. It looks like a hill. The other kind of curvilinear relationship would look like a U. So it just depends upon the data. With no significant relationship here, our R would also be quite low. Another feature of correlation is strength. And the closer a correlation is to 1, the stronger the relationship. For example, if I have a +8 or a -8 or a bigger number, we have a strong relationship. If we have a +0.5 or a -0.5, up to 0.79, positive or negative as well, it would be a moderate relationship. And if I have a ± 4 or a smaller number, 0.39, 0.38, 0.25, positive or negative, that's a weak relationship. So with a strong positive relationship, as we saw up above, we're going to have a very consistent set of dots. The more perfect it is to a straight line, the stronger. And the closer to the dots, if I draw my line of best fit, almost all of those dots fall right on the line. So this would be a good guess for an R of almost 1. In this case, a positive 0.97. For a weak positive relationship, it's still positive. There's going to be a very slight upward slope, but we're going to have a much bigger cloud of dots, as it were. And many of the dots are going to be fairly far away from that line. And our line might look something like this. It still has an upward slope. It's much flatter. And again, many points, in fact, more points are not on the line. So our R value would be quite small. A scatter plot, along with the line of best fit, gives us a good picture of any correlation. With correlation, we can open up a data set and then select 2 variables to explore. Our data has to be in actual numbers, so it needs to be a quantitative number. For example, let's say we're wondering about shoplifting in a department store. We could actually explore and see, is there a relationship between the number of clerks working and, say, level of theft? And that could be measured in value of shoplifted merchandise in dollars. Correlation is used quite frequently by many agencies, schools, hospitals, and businesses to see, as it were, to get a picture of the kind of impact one factor has on another. Let's use this example for an on-the-job scenario, shoplifting. Your boss has asked you to meet him in the conference room. He shares an email with you from corporate headquarters. He needs to figure out how to reduce profit loss due to high levels of shoplifting. With high unemployment rates and a high cost of living, shoplifting is at an all-time high. He has asked if you can help identify a quick solution to this problem. He has to submit a report along with recommendations to the corporate office in 2 months. You read over the email and you give him the A-OK sign. And you say, "No problem, I'll get right on it and report back in 1 month." He's very happy with your positive response. As the assistant manager, you've taken a lot of time to walk the floor of your department store, and you've noticed that many checkout counters aren't even open. Fitting rooms aren't supervised, and help at the jewelry counter is available, but only from 8 a.m. to 4 p.m. You collect data to identify when merchandise is being taken, by day of the week and by time, including different shifts. You are able to access information that tells you how many clerks are working each shift. Here's what you come up with. Here are the numbers from 1 month of data collection. You're now able to analyze the relationship between the number of clerks working and level of theft in your department store. So you can actually use this to create a scatter plot by hand. You can do this there where you're sitting. Get out a piece of plain paper or graph paper and label it. Put X over here on the X axis and write number of clerks with some numbers 8 through 15. And over here in dollars, 500, 1,000, 1,500, so forth, up to 3,500, theft in dollars. This is your Y axis. So now we could actually take our data and plot these out. And this is what we would come up with. We can see that we have a steep line and that we have a negative relationship. The dots are fairly close to the line. So I'm going to guess, my best guess is that we have an R that's fairly high, a negative 0.8, 0.9, something along that line. Let's check our results to actual output now from SPSS. We have an R that is negative 0.93. We have a very, very similar steep line sloping downward. In fact, this correlation is very close to a -1, 0.93. You take your findings and you report to your manager. Your results are staggering. There is a very clear pattern here. Your hunch was correct. You felt that perhaps theft was related to how many clerks were working. In fact, let's look at our actual numbers. We're going to be able to make a very strong case and a strong report to your boss. With 8 or 9 clerks working, theft is at $2,500 to $3,100. When we have 14 or 15 clerks working, theft was $500 to $1,500. By having more clerks on duty, you're going to be able to reduce or cut theft in half. Way to go! Your boss is very impressed with your performance and your ability to use statistics to help your department store find a quick solution to shoplifting. This could lead to that promotion sooner than you think. Congratulations! You've completed my webinar on correlation. Correlation is a measure of the relationship between 2 variables. We looked at the types of correlation and the strength, strong, moderate, or weak. Then we looked at a number of scatter plots to get a quick picture of what's going on with data. Lastly, we used an actual data set to create a scatter plot by hand, and then we compared our results to output from SPSS. Please let me know if you have any other questions. Call me or send an email or text, and I'll get back to you right away. I welcome your questions. Talk to you soon.